Hi everyone, welcome back to Data Hikes. We saw in the last lectures how to create and manipulate the structure of a table, right? And how we also looked at how to add or update or delete rows from a table. Okay, so now the table is created, the table exists. The main part and the most common use case for SQL is querying a table, like I said before, which means asking the table for specific data. How do we do that? We mainly do that using the select, from, and where statements. This is a very broad overview of this, but this is the starting point. We'll learn about more complex and intricate ways of asking for data from a table, but this is like the basic, right? So we want to start from the select statement, the from, and where statement. And we will go over what each of these mean in this lecture. Let's start with select. Select is basically used to pick specific columns from a table. Here we are selecting, quote unquote, the columns of a table that we want to see, right? So if the table looks something like this, it has 4 columns, 3 rows. If we use a select statement from it and specify which columns we want to see, maybe we wanted to see only columns 1 and 2, the table will be a thinner table, if that makes sense. This table was very wide, right? This table will become narrow or thin when we use the select statement. It's basically, you can think of it as, it is used to slice the table vertically. So if you cut the table from here vertically, you get the result, and that's what the select statement does. The select statement reduces the number of columns in a table, but it keeps all the rows. So we'll get to how we manipulate the rows, but for now, understand that the select statement vertically slices the table, which means that it reduces the number of columns in a table, but it doesn't affect the number of rows in a table. Now let's look at what the syntax for the select statement is. Here is how it goes. Select is a keyword, right? It can be written in capital letters, small letters, however you want to do it. You write all the names of the columns that you want to see. You can write them in any order that exists in the table. And then the from statement comes into picture. The from statement is followed by the table name from which we are asking for this data. This means if the table's name is, say, for example, student, then we will say select whatever columns we want to see, say name and ID from student. But now let's see an actual example. And this example, the name, when you look at it, may seem a little overwhelming, may seem a little daunting, but I will walk you through exactly how the name works and how you can actually, query this table. The example here is from a publicly available data in BigQuery, which is called Chicago Crime. And let's have a walkthrough of that table first. So for the DDL and DML commands, we saw how to do that in PostgreSQL, right? But BigQuery has a free tier, which is pretty cool. BigQuery is basically Google's own cloud platform to perform SQL operations, and they have their own existing public data sets that anybody can use. They also have a free tier by on which you can just go on Google Cloud. You can literally just Google BigQuery free tier, and you'll find out exactly how to set it up. And then you can use all the kinds of public data that is available on BigQuery. The data that we will be using, for example, like I showed on the slide just now, is the Chicago crime data. So just type to search crime in here, hit enter, and these data sets show up, right? And the trick or shortcut in BigQuery is to press control or hold control and hit the table name. So this is the database name in BigQuery, and this is the table name. So you want to look at the crime table within the Chicago crime database. So click here, and the crime table opens up. This tells you all the kinds of columns that exist in the crime table. A nice shortcut, a nice way to see your table and your query at the same time is to hit this little arrow and say split tab to right on here. So you can see your table's structure or your table's columns on the right side. I know it is very overwhelming to look at all these different column names to understand what they all mean, but As we go slowly, we can take it one at a time and just focus on the queries that we'll be walking through today. So this is the table, and these are the details of the table. In the details of the table, you can see the table ID, right? So this is the name of the table. And Google has this really cool way that you can just copy it. So hit that, it's copied to the clipboard. Now, you know the backtick sign, which is basically next to or to the left of the one on top of your keyboard. You hit that, you paste the name and hit that backtick sign again. This is how a table's name is written in BigQuery. And what was the query that we just saw again? It was select unique key, date, primary type, and arrest from this table, which means we are selecting specific columns from this big table. How do we know if it is a big table? Let's just do select star from this table. What does star mean? Star means select all columns, right? So all means star in SQL. So highlight the part that you wish to run and hit the run button on top. This will give you all the columns and all the rows in this table. So it has so many columns like we saw earlier. And how many rows does it have? It has 7.95 or almost 8 million rows, which is about like 80 lakh rows in there, right? So this is what how many rows we are dealing with. But we now only want to look at specific columns. A question for you is, do you think the number of rows will change if I select specific columns from this table? The answer is no, because like I said before, the select statement only affects the number of columns in a table and not the number of rows. So the number of rows would remain the same, which is the 7.96 million number. Now, BigQuery also has this really cool way that you can select fields in a table. So you just click them to select them. So you can also just click the fields and to select them. So the fields that we want to see are unique key, right? Just click on the next one you want to select, date, primary type, and arrest, and they just appear in that order, in the order that you click them, with commas between them and everything. So you don't even have to worry about the syntax. But just for the sake of it, let's practice just typing them in, because that's the conventional way to go, and you can still have some help from BigQuery to do that. So you want to say unique key, and it gives you a prompt which you just hit enter and it shows up, right? Unique key. The next one is date. The next one we have is primary type, and the next one is arrest. So these are the 4 columns that we wanted to see. Now let's select this part and hit run. Now you see this scroll bar is so short now because only 4 columns are now displayed. You can see you only have the unique key, date, primary type, and arrest. These case number, block, description, all of those columns are gone. You still have the same number of rows though. So this is how the select statement can be used in BigQuery to only return specific columns from a table. Now let's look at the counterpart of select, the where statement. The where statement is used to select specific rows or to pick specific rows from a table. Here we are just asking the table to show us the rows that satisfy a specific condition. So you have 4 columns, 3 rows. The where statement will only return the rows that satisfy a condition. So it won't affect the columns at all. The columns, like we have seen, are dictated by the select statement. So whatever the select statement tells us, that's how many columns we have. But just the where statement does nothing to the columns. What it affects is the rows. You can think about it like a select statement slices a table vertically, the where statement slices the table horizontally. It only reduces the number of rows in a table. It can only reduce the number of rows in a table. Let's see how the syntax works. It's again, select how many ever columns you want from the table name, and after that you write where condition. Now, how might a condition look like? Let's look at an example. Select star, like I said, select star means select all columns from a table from the table that we just saw, where primary type is equal to kidnapping. So kidnapping, notice that it's in single quotes because primary type was a string type of data in the table that we are looking at. So let's try this statement. Let's try running this. So let's just copy paste this part of it, right? We can just write the same statement because it's coming from the same table, right? But select star from that table and then add where primary type equals kidnapping. Again, the where statement slices the table horizontally. So what we should see is fewer number of rows in the result that we get from this query, right? So it is returning all columns to us. So now it won't be just these 4 columns. We are asking for all columns, but only the rows where primary type equals kidnapping. Like I said, primary type is a string type of data. So only the cases where this condition is satisfied will be returned. So let's select it and run. See, the number went from like almost 8 million to just 7321, which is a very small number compared to the big number that we were seeing. So only 7,000 or 7.3 thousand out of the 8 million rows that were in the table were cases about a kidnapping. I don't know what that tells us, but that is the information we got. And like I said, the where statement doesn't affect the columns, and because we said select star, we are seeing all of the columns in here, right? So that is how you use the where statement in SQL. Alright, so we have seen how the select statement and where statement work individually, right? Now let's combine them. And when you combine the two, the query looks something like this. Basically, we are just using both things that we did in the same query. So we're selecting specific columns from the table that we are using, and we are also adding the where condition in there. So where primary type equals kidnapping, right? So this is a combined query. Now let's just go over and see how SQL understands a statement like this, right? So let's start with the order of execution. What happens first when you run this query? What does SQL see? It looks at the from statement, the very first. So it knows that I'm getting data. So the universe for this query is the crime table under Chicago Crime Database. So it has all the columns going from this to like the end of the columns. I couldn't even fit them in here in the screenshot. You have, of course, all the rows. So you start with 1, 2, 3, 4, 5, 6, go up to like 7.95 million rows, right? So that's a lot of rows, a lot of columns, and this is the universe for this query. The next thing that SQL understands is, okay, I have the table that I need information from. The next thing it does is the select statement. Like I said, select statement slices the table vertically, right? So when the select statement gets involved, it knows that, okay, from this entire set of columns, I only want to see these 4, right? I only want to see the unique key, date, primary type, and arrest from this entire big list of columns that this table has. But again, notice that the number of rows has not reduced. So the only thing we cut is the number of columns. So we reduced the number of columns, kept the number of rows the same. Why? Because the where statement isn't involved yet. What happens when that comes in? That comes in, the number of rows goes down from 7.9 million to 7,000 something, because these 7,000 rows are the only cases where primary type kidnapping was, this condition was met. So you can see in this result, all the values in the primary type column is kidnapping, because those are the only rows that we told SQL we want to see. And this is how you combine the select and where statement. Now let's run this and see how it works. So basically, we're actually just using a combination of these two. Oh, by the way, just notice that I added semicolons at the end of each SQL statement because we can't have multiple SQL statements without semicolons between them, BigQuery will try to tell you that you have an error. But we can continue with what we are looking at and say, hey, select these columns from here, and now I also want to add the where condition. So I say where primary type equals kidnapping. Run this whole thing. What do we expect to see? We expect to see few columns and also only few rows, the 7,321 rows, which satisfy the condition primary type equals kidnapping. There we go. We just have the 4 columns that we wanted to look at and only 7,321 rows. You can jump to the last page of the results by clicking this button, and you can see there are only 7,321 rows in this result. So this is how you get data from SQL essentially. You ask SQL for data from specific columns that you want to see and also specific conditions that you want to be satisfied for getting this result. Thank you for watching. Please like and subscribe if you enjoyed the video, if you learned a lot from it, if you learned a little from it. And I will continue making the SQL videos in the upcoming weeks, and please follow along. Thank you.